All right, students, we're here and we're gonna be talking about mid-segments, all right? Hooray, mid-segments. And we're really in the second phase of Unit 5. In the second part, we're really talking about centers of triangles, and believe it or not, there's 3 different kind of centers of triangles we're gonna talk about. And then mid-segments, they have some pretty cool stuff too. But nonetheless, this is a little bit different than what we were doing before, but super exciting. All right. Had a little typo there, almost canceled. But anyways, a mid-segment is a segment that connects the midpoints. Wow, a mid-segment is a segment that connects midpoints of 2 sides of a triangle. I wonder where we got that name from. However, this is what it's gonna look like. So if this is a midpoint that I just drew on the triangle, well, that side and that side are congruent. And if that's the midpoint of that side and that side is congruent, and connect them. All right, so that right there is an example of a mid-segment. So this is a big deal in your young life. This is the first time you ever drew a mid-segment in your life. You guys should feel pretty accomplished right now. Nonetheless, these are some tools we need. What I really like about this unit, or not this unit, this section, mid-segments, is that we get to practice a whole bunch of things we've learned. We get a slope, distance, midpoints, all these formulas we get to apply. So this is gonna be intense right here, a bunch of math going on. On the graph, we're going to draw a triangle with points. They're already there. Let's just label them. All right. So A is at 0, 8, so I'm going to call that A. B is at 6, 0, so I'm going to call that B. And C is 0, 0. All right, so we have this beautiful triangle, and we're going to find the lengths of A, B, and C. All right. Now, I purposely made the triangle the way I did. AB, we're going to use the distance formula. So again, maybe it'd be a good idea to pause the video right now and see if you can write out the distance formula correctly on your own, then check your work. All right, I like to write it out every single time just so you students practice it. All right, if I'm doing something by myself, I'm probably not going to write out the distance formula. Nonetheless, all right, so we wrote out the distance formula. Sometimes it's a good idea to label your points. I'm going to call A x1, y1. I'm going to call B x2, y2. Remember, it doesn't matter which one's which. All right, order doesn't matter in the distance formula, but we do have to keep organization, such as our x's have to be together and our y's have to be together. I called x2's 6, I called x1 0, so I plugged those in. I called y2 0 and y1 8. So remember the distance formula, plug it in, then it's just a bunch of calculations such as 6, and we must follow the order of operations. Parentheses. All right, parentheses is first, so 6 minus 0, 6 squared. 0 minus 8, negative 8 squared. All right, so just some computations. I did parentheses. Now it's time for me to do exponents. 6 squared, 36. Negative 8 squared is negative times a negative, gives me a positive, so 64. Square root of 36, 64, gives me 100, and the square root of 100 is 10. All right, so the length of AB is 10. BC, what's that? 6. AC, what's that? 8. All right, sorry, I got a little excited on those, but for these distances, I just counted. All right, that has a length of 6. That has a length of 8. Okay, horizontal and vertical lines we can just count. I got a little excited, but that's where those numbers came from. All right, so I found the lengths of all 3 sides of this triangle, all right? This is a slow build-up, all right, so stay with me. Now we're gonna find the slopes of stuff, all right? So again, I have the slope formula, and we're actually only going to use it for AB. But I'm gonna rewrite the slope formula, even though it's at the top of the screen right now. Because again, just writing out things helps us remember it. So the slope formula is y sub 2 minus y sub 1 over x sub 2 minus x sub 1. And again, order doesn't matter, but consistency does. Y sub 2, I already have these labeled up here. I already labeled them. 0. Y sub 1 is 8, so 0 minus 8 over x sub 2 I called 6. And again, remember I labeled the points right here. That's where I'm getting them from. So remember the slope formula, plug in things correctly. Now just do computation. Says that 0 minus 8 is negative 8, 6 minus 0 is 6, and negative 4/3. All right, so that's the slope of AB, negative 4/3. All right, now slope of BC, we can think of our best friend slope dude. This is 0, fun. This is 0, fun. All right, there's no rise, so it's 0. All right, and the slope of AC is the worst curse word in all of math. It's when he falls off the cliff. I'm gonna have to whisper it because it's a bad word. Undefined. All right, it's an undefined slope. Vertical lines have an undefined slope. UND means undefined. Okay. Now, that's intense. All right, so we found the lengths, we found the slopes. Now we're gonna find the midpoints of everything. All right, very dense, stay with me. All right, so the midpoint formula, recall, it's this right here, x sub 1 plus x sub 2. So you add your x's together, divide by 2. You add your y's together, divide by 2. It's really just finding the average value of each point. When you add two things together and divide by 2, you're finding the average of it. Anyways, so let's do it for AB, and then we'll just count the other ones. Because remember, all this stuff, there's shortcuts, but the formulas always work. Sometimes the shortcuts don't. But anyways, x sub 1 plus x sub 2 gives me 0 plus 6 divided by 2. Then y sub 1 plus y sub 2 gives me 8 plus 0 divided by 2. And then remember, the midpoint is an ordered pair, so it's gonna give me 3, 4. All right, it's an ordered pair, so basically it's saying the midpoint of AB is at 3, 4, which is right here, and it wants me to label it with a lowercase c. Sometimes it's hard to tell the difference between an upper and lowercase c, but that's a lowercase c. So that's the midpoint of that segment right there. Now we're gonna do the same thing, but for other sides. So BC, the midpoint of BC is at length of 6, so we just go to 3. I'm gonna label that lowercase a, and then similarly, AC has a height of 8, so the midpoint would be at 4, lowercase b. And I'll put some tick marks there just to emphasize stuff. Also, B is at 0, 4. We gotta say A was at 3, 0, and C was at 3, 4. All right, so this is great. This is almost a review of the year itself. We've reviewed distance formula, slope formula, midpoint formula. Now watch this. This is really important. We're going to connect all these points and create the mid-segments that we need. Bloop, bloop, bloop. All right, so we just created all the mid-segments. Now we're going to do the same thing, but we're going to find like the length of the mid-segments, the slopes, and that's it. And then we're going to realize some stuff. So slope of, or we need to find the length of AB right here. Now I did the distance formula last time, but remember we can use the Pythagorean theorem shortcut. All right, we can create a right triangle, which we actually already have right here. So in doing this, we see that the length of BC is 3 and the length of AC is 4. So actually, let's go write that down. BC, we need to find the length. It was 3. AC was 4. Now this right here we'll call X just for fun. We can call it anything we want. I'm going to use the Pythagorean theorem shortcut to find the length of AB. So x squared equals 3 squared plus 4 squared. X squared equals 9 plus 16. X squared equals 25. All right. And then I take the square root of both sides and x equals 5. All right, and right now what we're doing is very dense, it's very in-depth, it might seem spooky, it might seem a little scary. You're never gonna have to replicate this on your own, but I like doing this right now because we're reviewing a bunch of stuff, developing skills, and understanding where the mid-segment theorem comes from. All right, we're basically proving it through coordinate geometry. So don't be too spooked right now, it's not that bad. Anyways, we're gonna find the slopes of things, so let's just go ahead and count the slope of lowercase ab. It said find the slope of lowercase ab, which is this right here, and it's a rise of -4 down 4 over +3, so -4/3. Then BC, what's the slope of BC? 3, or excuse me, brain fart. The slope of BC, this is 0 fun, this is 0 fun, 0. Horizontal lines are 0, and then the slope of AC is undefined. It's a vertical line. All right, very in-depth what we did right there. Well, what's going on? There's some relationships. All right, did we notice that? Like, look at this. Let's look at the length of A. Actually, we'll just look at all the lengths. 10, 6, 8 went to 5, 3, 4. What's the relationship with these lengths right here? Furthermore, the slopes, -4/3, 0, undefined, -4/3, 0, undefined. Oh, what? They were the same? So, this is it. This is the mid-segment theorem. What conclusion can we make about the relationships between mid-segments and the triangle? Well, the segment connecting the midpoints of two sides of the triangle is parallel. All right, did you notice that they had the same slopes? All right, to emphasize things, looking back up here, like this line, uppercase BC was parallel to lowercase bc. So on and so forth. I could do it for all I'm not though, but lowercase ab is parallel to uppercase ab. So the mid-segment's parallel to the opposite side, and it's half its length, which kind of makes sense. It's a midpoint, it's cutting it in half, so it's half its length. And we saw the 10, 6, 8 up here. We had a length of 10, 6, 8. We had a length of 5, 3, 4. All right, so very in-depth stuff what we just did. Are you ever going to have to replicate that on your own? 99.9% sure you won't. But in the next video, we're going to practice it again because these are just really good skills to have. It's a good review of the past and skills we